Hi children, welcome back to our class. Last 3 classes we have seen chemical reactions and the balancing of chemical reactions. Today we will see the types of chemical reactions. There are different types of chemical reactions. One by one we will see that. Okay. So on moving to our topic, types of chemical reaction. The first one among the type of chemical reaction, first one is a combination reaction. Combination reaction. We can see what is a combination reaction. So in that combination reaction, 2 or more than 2 different reactants, different materials are combining to produce a single product. Different 2 or more reactants are reacting to produce a single product, then that type of reaction is known as a combination reaction. There is a familiar example for you. Carbon plus oxygen gives carbon dioxide. It's a combination reaction. In this carbon and oxygen, 2 different reactants are there combining to produce a single product, that is carbon dioxide. That is a familiar combination reaction for you. Okay. Now we can see another combination reaction. In that case, we can take calcium oxide. Calcium oxide is also known as quicklime. Quicklime. Commonly it is known as quicklime and chemically it is known as calcium oxide. And we can add water to this quicklime. Adding water to quicklime is also known as slaking of quicklime. Slaking of lime. We are calling it as the slaking of lime. And when water is added to this quicklime, we will get calcium hydroxide. That is actually slaked lime. Calcium hydroxide is known as slaked lime. Slaked lime. So adding water to quicklime gives slaked lime, and in this 2 reactants are there but only a single product. So we can say this is an example of a combination reaction, and in this particular reaction the reaction will be highly vigorous reaction. Slaking of this quicklime will be a vigorous reaction. Lot of heat energy is liberated out. This is an exothermic reaction, and as it is an exothermic reaction, we are adding water there, and during this reaction, while the reaction, energy will be liberated out, which makes this water to boil. So there will be a hissing sound will be produced there, and water will start boiling there because of the liberated heat energy. So this is an exothermic reaction. Exothermic reaction, and in this is also a combination reaction, but mainly what type of reaction is it? We are asked to mention the type, that is combination reaction, and main type of reaction is combination only, but in that section under that subdivision will come as exothermic. So main what type of reaction, it is combination only, but during that time energy is liberated out, hissing sound will be produced. See, you might have observed that when we are pouring water or dropping water to a very hot pan, tawa, that sound is actually known as hissing sound, and that sound will be produced here as it is an highly exothermic reaction. Okay, so this is a combination reaction, and in this case carbon and oxygen combination to form carbon dioxide, that is also, this is a burning process, and during burning energy is liberated out, that we know, right? So burning of natural gas, that is methane, when reacted with the oxygen, carbon dioxide and water will be produced. So all these burning process, it is combination with the oxygen. Okay, and in the case of respiration is also a combination reaction. At that time glucose is combining with oxygen and energy is liberated out. In that time product may not be a single, more than one products are there, but it is also an exothermic energy in which energy is liberated out. At that time also that reactants are combined there with the oxygens. Okay, so more than two reactants, two or more than two reactants are combining there to produce a single product, then that reaction is actually known as combination reaction. And decomposition of vegetable materials into compost, vegetable compost will be there, that formation is also an exothermic reaction. Okay. And then we can see the second case, that second type of reaction we can see as decomposition reaction. Decomposition is the opposite of combination reaction. Decomposition reaction is the opposite of combination reaction. Okay, that means more than a single reactant is split into more than two or more than two products. That is just opposite of the combination reaction, and this decomposition reaction will be done in presence of different types of energies. For example, sometimes the decomposition reaction will be happening by when we heat that material. Okay, if we are heating that, we will call it as that particular decomposition we will call it as thermal decomposition. Heating, during heating if any material is undergoing splitting or decomposition, that is known as thermal decomposition. Okay, so it is classified into three: thermal decomposition. Thermal decomposition, at that time simple heating of a material, for example ferrous sulfate. Ferrous sulfate is green in color. Okay, its color is green in color, and that ferrous sulfate, if you are heating it in a test tube, at that time Fe2O3, we will get ferric oxide and then sulfur dioxide and sulfur trioxide. So we can show the states, the gas, this is solid and this is also solid. Okay, but the equation is not balanced, we can balance it. We can balance it. Fe2SO4, if we are heating that ferrous sulfate which is green in color, we will get a brown material. Ferric oxide is brown in color. So that color change will be here, brown in color, and we will get a pungent smelling gas. That is a mixture of sulfur dioxide and sulfur trioxide. This reaction is a particular reaction in which color change is happening. So while heating, we can observe that green color to brown color, and whenever you are doing that experiment, you have to keep the test tube mouth away from your face, so that nothing will happen. Okay, no burning and nothing will happen, so you have to keep it away from your face. And that gases will be produced there, you have to smell it. So you have to wave the hands like this to get the smell. So the gas will come to your nose so that you will smell it. You can identify the pungent smelling gas, which is a mixture of sulfur dioxide and sulfur trioxide. So this is a example of a thermal decomposition. Then another example for thermal decomposition we can see is heating lead nitrate, PbNO3 twice. We are heating that lead nitrate, and on heating that lead nitrate we will get Pb, lead oxide, the PbO, and nitrogen dioxide we will be getting the, and we will be getting that oxygen also, the O2, and we have to equate that nitrogen 4. So here it is also, here it is 2. So 2, if we are putting that so at that time we can equate it by keeping that. So this is the balanced chemical equation, and lead nitrate on heating that will reddish brown fumes of this nitrogen dioxide will be liberated out. That also is an observable change. Okay, lead nitrate, which is white in color, and we are getting the yellow colored lead oxide and brown fumes, reddish brown fumes of nitrogen dioxide will be produced there. So we can observe that reaction has happened there. This is also an example of a thermal decomposition. Then another example for thermal decomposition, one more example which is familiar to you, calcium carbonate on heating. On heating, calcium heating we can show as delta the calcium oxide plus carbon dioxide. This is a familiar example for us because this equation we have taken for studying the law of conservation of mass. So, this particular equation, this is also an example for a thermal decomposition. Okay. Now, we can see second type of decomposition reaction, that is D, decomposition using light, that is photo decomposition, or we will call it as photolysis. Lysis means splitting. So, in presence of light only that the splitting is happening. Photo decomposition, that example silver bromide. Silver bromide in presence of light, if you are keeping just sunlight, if you are keeping it, the silver bromide will be splitting into silver and bromine. Bromine is 2. So, 2AgBr will be split into 2Ag plus Br. This is a photo decomposition reaction, and this is yellow in color and grey color silver will be obtained. Same way, silver chloride decomposition also is the silver chloride also undergo decomposition. AgCl, silver chloride, that is also undergoing decomposition in presence of sunlight. Here also sunlight, Ag plus Cl. Here also we have to balance it. So, in this case, this particular color is white there, and again we are getting the grey colored silver there. So, this is also happening there in presence of sunlight. So, this is photo decomposition reaction. So, decomposition reaction which is happening in presence of light. So, when you are asked to write the definition of decomposition reaction, just a decomposition reaction. But in case of photo decomposition, you have to write the decomposition reaction definition there, and that decomposition takes place in presence of sunlight, then that will be photo decomposition. Then the third decomposition reaction is there, that is in presence of electricity. In presence of electricity. Electro decomposition. In presence of electricity, the reaction, decomposition reaction is taking place, then that is known as electro decomposition. For example, when we are passing electricity to water, water is in the liquid form, on passing electricity to water, water will be decomposed to hydrogen gas and oxygen gas. So, water will be split into its components by passing electricity through that, and the amount of volume of hydrogen gas collected will be double that of oxygen, because more number of hydrogen is there, volume of hydrogen will be more there, and all this will be taking place in presence of electricity only. When we are passing electricity to that water will be undergoing decomposition, that is known as electrolysis or electro decomposition in presence of electricity. Electrolysis, another name is electrolysis. Okay, so all these are the three different types of decomposition reaction. Just decomposition reactions are opposite of combination. Combination reactions are exothermic. So all these decomposition reactions are endothermic reactions. So example for endothermic reaction, all these are examples. Thermal decomposition, photolysis, electrolysis, all these are examples for endothermic reactions. So decomposition reactions are all endothermic in nature. Okay, I hope the topic today we discussed is clear to you. Thank you.